to talk about the accelerating innovation with the power of advanced simulation optimization techniques. May I please invite on stage Xavier, Vice President, Dassault Systems, and Shree Harsha, Consulting Director, Transportation and Mobility, Dassault Systems, India.
Thank you. Good morning. Sorry, started with this video because CFD is really important for the car industry. You know that at 60 km/h, and for sure above, more than 50% of the power you spend is on aerodynamics. So first I want to start this by thanking ETAuto for hosting us and for inviting us to present at this very impressive conference. So I'm really impressed to see all of you. So thank you, ETAuto. So my name is Xavier. I'm in charge of consulting and sales for the automotive industry. And with my colleague Shree Harsha, we would like to show to you how we see simulation in the automotive industry in general. So to begin with, what I want to say is a few words about Dassault Systems. So we are a scientific company taking science and applying it to the industry, you know, by putting in place solutions which are allowing our customers to design product, to simulate and validate them. So we have 16,000 people. It's now a large company. We started more than 30 years ago, and we started out of our aerospace, but I will show you in the next slide how important automotive has become to us. We're a large base of customer. I want to say we have also a wide presence in India. We have more than 2,500 people in India. We have several R&D labs. And by the way, we have a significant number of R&D labs worldwide because we have made acquisitions of technologies and we keep the R&D labs where they are and we work all together on this. We are a long-term driven company. We have the chance to be family owned with a majority shareholder of the family, which is allowing us to have long-term vision and keep the operating margin that we make internally to reinvest. I think we're on clearly one of the leader, if not the leader in PLM, with more than 3.2 billion euro revenue, and this is all software and a bit of service, but mostly software. So as I mentioned, what do? We provide to our customers the way to design, to validate, and to experience. And we do this, with digital continuity. I think that's one of the keywords I want to pass to you, is that in order to be efficient in innovation, you want to have a streamlined base where you can do the design and you can do the validation, the simulation in the same environment, avoiding to do data transfer and data transformation. So for sure, we do system design, not only geometry, but we also do complex system design. We have all or most of the physical models and simulation software to validate this. And at the end of the day, we also provide the environment where our customers can do virtual experience. Here we see BMW, who is doing virtual driving simulation based on, for sure, the model, the geometry, but also the critical physical qualities and all the equations of movement and so on. So what I mentioned about automotive. So we started off aerospace in 81, but very soon in 82, we already went to customers like BMW and Honda. So automotive industry is a key industry for us. 1/3 of our revenue comes out of automotive. It's our first industry. And all the names that you see here are companies who have designed or validate and simulate their products with our solution. One thing is cross-fertilization. We work a lot in these different industries. Aerospace is our second industry. And there's a lot of common things which we can build upon. I mean, a lot of things we do, for instance, in simulation, control command with aerospace industry is now becoming a part of automotive. Same story for long-term archiving, simulation. All of these things are common through the industries. So this industry is going through tremendous pressure. And I have to say that I've been in this industry working for this industry for more than 20 years now, but it's only now in the last few years that we see all these forces converging and kind of bringing a big storm to the industry. So for sure the trends, you know them more than we do, and it's electric, it's autonomous driving, which will lead to a new model, a new business model of shared mobility. It's new customer experience, whether it's for driving the car or watching the car being driven, whether it's for selling the car and buying it. All these are new ways that the customer are expecting you to provide tools. Huge pressure on quality and cost. Quality and cost has always been a pressure, but regulation is becoming more and more, I would say, heavy on this industry. And we will see how simulation is a key part of this. And this has already been presented by Volvo Harsha. So I think it's no news. And this is the center of what we are going to talk about. And for sure, mass production, which is now becoming mass customization. Because customers, if you want to make better revenue and better margin, you want to be able to customize what they're looking for. So all this industry is being shaken by all this, and you have a lot of startups who are coming and emerging out of this, and they're kind of transforming the industry. If you take Tesla, it's no longer a startup, but Tesla is a relatively small company, but its market cap is bigger than GM, Ford, and it's really Tesla plus the regulation is really pushing everyone toward electric vehicle with the huge investment that it means. And so you have Tesla, yes, now no longer a startup, but you also have companies like NIO. They started a few years ago and they've got 5,000 people working worldwide. And you have all these small new players who are really coming up and who are going to shake this industry in a way that's never happening. And trends in India are no different. You're under the same pressure, actually even bigger. If we look at the progress that have been made on the Bharat stage emission norms, it's huge, and we are at 4 now, you're going to 6. It's going to be even more difficult, so you have this really strong pressure. Same on crash, moving to tougher, more stringent norms. Quality expectation. India is growing fast. People are more affluent. They look for better cars. So you have to be able to stand up to new quality expectations. And last but not least, electromobility is happening. It's going to take a while because there's a lot of infrastructure challenges to it, but it's happening. So you need to go there. quickly, clearly. And how do we go there? So, you know, to survive and to prosper, you need to innovate more and more, even faster than before, whether it's for the virtual development, which we have seen changing from 3 to 6 years to now 3 to 4 years. Next time is going to be 1 to 2 years, and it's going to be not only developing a product, but developing an experience. So this in itself is a challenge, but it's also virtual validation, you know, less prototypes. Hardware prototypes is costing a lot, and you do this at late stage of simulation, which means it's costing even more when you want to modify, so you need to drop down the number of physical prototypes, and you need to go virtual. Production, we're not going to focus on this, but obviously we're going to lean production, we're going to flexible production, smart production, and for sure it's key, as well as virtual sales. I mean, this selling is no longer going to happen. You already have a lot of showrooms everywhere, not a single physical product. Every product is being simulated. Tomorrow, people are going to buy from home with a headset. We already do this, you know, at a virtual point of sales. If you take some brands, they're already selling it like this. Tomorrow it will become at home, will become a reality, because it's coming anyway in the gaming and so on. So it will happen this way. So if you want to innovate, not only you want to innovate to make better products, but you also want to innovate and to simulate just to survive. If you look at these products, you know, all these products, it's happened for sure on cell phones, happened on the Indigo. You know, Indigo, if you look, they had a lot of issues with the A320 because of the engine issues. If you take the Silvercrest program, it had to be stopped actually because it was delayed because performance was not there. And this had drastic impact. I mean, these last stage issues, they actually, some companies could not recover from them. So these are a few examples. So not only you need to simulate to do better, but you also need to simulate to survive. So now I would like to invite Shree on stage to tell us a bit more on how consistent simulation can actually improve not only product, but also process and ultimately profit. Please, Shree.
Thank you, Xavier. Good morning, everyone. So that was a very good introduction by Xavier in terms of how the industry is setting the stage. And now I would take a shift in terms of giving you a perspective of how simulation technologies are catching up to really meet these kind of new norms, new expectations from the customer as well. At the bottom of all of these discussions is primarily our belief that the virtual universes, or what we call as the virtual world, will help us to really, better the real world. What do I mean by that? It means the ability to innovate and conceptualize what potential possible scenarios the product which you're expecting the customer to be used is envisaged, modeled, and simulated will help you to, number one, improve your quality and reliability, and obviously your brand image as such, but not necessarily that. It has a drastic impact on the amount of money you spend on the physical prototypes. So in the next 10 minutes, I'm going to take you through some of these examples of which are the new simulation techniques which are coming into the market, which will help you to really put your thoughts into this framework and why are we doing with what we are doing and what's the final intent as such. To go back to the basics as such, I mean, we have been using CAD tools and CAE tools for many, many years. I mean, all of us here in the room know the impact and the meaning behind it. But the only reason why it's all the more prominent right now is because of the interdependency of the multidisciplinary domain and the corresponding impact it has on from the changes from one department, what has been done, to the other departments. Let me explain that with a small example. If you take a motorcycle, if I take the brake disc, the front brake disc of a motorcycle, you have a lot of issues with regard to the design of it. For sure, you need to achieve a certain braking distance. You could have material issues with corrosions, and you could have a lot of vibrations which needs to be taken into account as well. Not necessarily that, but you need to make sure that during the Indian monsoon, it is pretty well protected with corrosion, and you got to make sure that it's lightweight as well. Added to that, there are quite a lot of issues associated with performance, robustness, reliability, safety, and finally, eco-efficiency as. So if you see, really, the CAE team is always under pressure with contradicting requirements. On one side, you need to have best in class, On the other side, you got to really be highly efficient as possible with lowest cost, with the best of materials usage, and making sure that the production is not impacted as well. So that really calls for a methodology change in the way we really simulate and design. And we are saying that the ability to really front load the CAE simulations as much as possible right in the conceptual engineering phase, and to be able to bridge the gap with the number of iterations you need between the CAD and CAE, that's where is the key development criteria for an optimization technique to come in, and the software to tell you what potential possible alternatives out there, and the designer and the CAE engineer can sit together and converge sooner. And I'm going to take a small, a 1 minute video to illustrate this on the brake disc as example. Can I launch the video, please? Slides, please. Thank you. So this was a quick summary in terms of what I was trying to tell you, that the ability to be able to come out with huge alternatives and converge on that between the CAD and the CAE, and how do we really converge on the faster is what is going to be my topic of discussion. So what did we really do in this small illustrative video is we took the product spec as what sort of dimensions we need, what sort of technical parameters we need for the brake disc, and we went into having a physical virtual model with regard to the various set of thermal properties, structural properties, a model associated with NVH, and then put the software in the back end to really say that, look, whatever the systems you would potentially use, come back and propose to me the best alternative design spec, taking into account all sort of constraints, and then give me a spec which is, meeting to my KPIs. That's exactly the direction which many of the design and the simulation world is converging right now, wherein more and more, instead of having a siloed approach where design will send you the design and the CAE team will start meshing, and then after 3 weeks they come back and provide the feedback, we would potentially lose time. And this is a new dimension. Now I go to the next step of why we're really doing what we're doing. So end of the day, we are actually trying to really have an impact on prototyping costs, engineering resources associated with this kind of activity, and obviously the production costs associated with this by simplifying the manufacturing processes. We are reducing the material. That has a significant impact on the overall cost. And of course, as one of my colleagues and as RSS also pointed out, the warranty claims is another big issue. Customers expecting like 5 years warranty, 7 years warranty. Who's going to really run those drive cycles and make sure that the reliability is promised to the customer for those kind of things? And that's bringing to my next dimension of my thought process. Traditionally, we have been talking about structural simulation, thermal simulations, maybe CFD as a separate thing. The new dimension which is evolving, I mean, most of us know is multi-physics for sure. We're talking about structural, thermal, fluid. But with the advent of this electromobility, there's a new dimension of simulation coming all together, which is electromagnetics. And second is control systems. And the dimension of biological impact of various set of, environmental conditions as well, and not last but not least is the chemical factor of simulation as well. This is from a multi-physics perspective. Another dimension altogether which is impacting the fundamental research and applied research is the scale of simulation. It means, are we talking about simulations at a molecular level to come out with new materials to address the problem? Are we talking about next level of physical characteristics at a part level or a system level, or even go one level up of how do I design a mechatronic system which has got 5 or 6 use cases, and how do I solve this problem? And that's where new domains like model-based systems engineering are coming into picture. So our acquisition strategy, actually, if you really see, no one company can master all of this as well. So in this market right now, we see new companies are evolving who are doing fundamental research into this new domain. For example, I would like to highlight this one company of a German company which we looked into. They are into fundamental electromagnetic simulation. It means, where do I keep my battery pack? What's going to be the radiation levels of the battery pack with the passenger which is going to sit on the floor, basically on the seat of the car, because the battery is kept on the chassis, basically on the floor. So these kind of questions on where do I keep my radar, will it affect rest of the other domains as well, is some of the questions which needs new answers and new simulation techniques, and that's where a lot of research is going on in the market right now. Coming back to the battery as such, specifically with the vehicle electrification, people thinking that, if I put a battery pack and if I solve my range characteristics, I'm done with that. But that's one piece of the problem to be solved. Fundamentally, there's a huge amount of research, battery research, which is needed in this country to really to be able to do localization of the batteries, come out with new set of technology beyond lithium ion, as well as new technologies associated with charging and the range. Moving ahead, we can come on to the cell level and have a better battery pack design, because we're not even thinking that if you put a battery pack for 400 kilometer range, and what's going to be the impact of crash on the front or the side, and will the vehicle explode or not? I mean, we don't know. All these are new dimensions of simulation we haven't even thought about as such. So that comes to my last aspect of my thought process, which is the ability to really navigate the engineering dependencies associated with thermal, chassis, vehicle architecture, electronics, HVAC, and to be able to really have a decision-making system to get the KPI impact associated, and the trade-off is where is the next innovation is going to be. It's not going to be a siloed waterfall approach anymore. It's going to be more collaborative, a huge cross-functional team working together to come out with answers and solutions faster with the new dimension as such. And these are some of the examples which I was talking about right now. There are wireless charging cars coming in as we speak. The people talking about where do I keep my radars and antenna for driverless cars, and what do I do about the vehicle-to-vehicle communications? We're talking about various set of techniques. So the ability to really visualize first, number one, model it, simulate it, get access to the behavioral conditions of what could potentially happen on the road conditions. Numerous amounts of lakhs of lines of codes has to be tested. Can we afford to do them in the physical world? Do we have so much time? Not necessarily. And that's where simulation is going to play a huge amount of role. To summarize what I just said, end of the day, we are moving from requirements to design and to simulation and to the results to come out with the best possible alternatives. And simulation is actually aiding you to do the trade-off studies. How do I do a trade-off with the kind of costs which I can incur, with the kind of price targets which I'm targeting at, and within that constraints, what best I can deliver to my end customers. But that's not all. Virtual testing is one piece of it, but we have physical testing as well. With physical testing, if you really see, the amount of time and effort spent is much more. The cost involved in physical testing is multiplied by 5. And as you can see on the screen, the virtual aspect talks about just CAE tool sets and HPC, high performance computing machines, and high course machines, so that you can run and come out with solutions. But if you go into the physical testing, we got to really procure prototypes, order them, and they're expensive, and the kind of tolerances we are talking at an engineering level is very, very high. I mean, we have a number that one of the European OEMs spends roughly €1 billion on just physical testing alone. And added to that is 3 dimensions of thought process. How do I really manage this huge number of test data? Second is, how do I align with my budget? And last but not least is basically taking that, how do I do a correlation between the CAE test and the physical test? So the convergence of why we're doing what we're doing come very clearly, can we address while we converge on what we do with CAE and what we do with physical tests, and make sure that we converge faster and quicker. And that's exactly a summary of my slides. On the leftmost side is basically 15 to 10,000 tests. That's the kind of test cycles which we have for the various different domains in a typical automotive product development. And the bottom side is various test rigs which you already have, and maybe spread across India, or maybe outsource some of the testing. So there's a test strategy which is executed typically to really come out with which test is performed by whom and by when, and what is the cost incurred as such. And there's a humongous amount of data collected with physical tests. And this is light in various set of servers rough across. So companies which are able to navigate and come across a methodology to to get this physical testing teams and the virtual testing teams and R&D work together will actually get an upper hand in this end of thing. So with this background, so can I call upon Xavier to summarize what do we really mean by it and how the simulation technology would evolve so that we give the kind of message of where Dassault Systems is going. Thank you.
Thank you, Shree. So at the end of the day, what is it? As Shree mentioned, it's not being able to perform simulation point by point, it's being able to master it all together. The key thing will be how can you put it all together to actually organize your compromise, because this is a story of compromising. How do you compromise performance against cost? How do you compromise safety against regulation? All this is going to be key, and it's going to be key if you can make it at early stages. So maybe we can show this video to conclude, and then we will be finished. So this is a video of design of experiment where you actually are being able we made a parametric car, and we can change parameters. As you see, when we change parameters, we actually see immediately the consequence in terms of drag or in terms of lift, which means that when you are doing that at design level, you can already take some decisions in terms of the design of your car on what you're going to take as an option of design, which will have consequence on the drag of the car. Just an example, but I think it really summarizes what we want to pass as a message. You're going to be successful if you can manage your cycle, quick loops, and quick iteration between design and simulation. So with this, I would like to go to my last slide and to thank you. And again, thanks ETAuto. So thank you for your attention. Thank you.